experiencing a strange sensation. A feeling as though there's something bad out here. A malevolent presence. The one thing we didn't want to encounter. Impossibly black, blotting out the stars behind it. We are staring into the face of extinction. The remains of a giant star. A black hole.
A black hole is a region of space that has a gravitational field that is so intense that no matter or radiation, including light, can escape. There are 3 types of black holes: stellar, intermediate, and supermassive. But before we talk about the different types of black holes, let's talk about how they are created. Anything can become a black hole, if it is compressed into a small enough space. This amount of space is different for every object, and is called its Schwarzschild radius. For example, if Mount Everest were to be compressed into an object with the radius of 1 nanometer, it would be a black hole. This means that 1 nanometer is the Schwarzschild radius of Mount Everest. If the planet Earth were to be compressed into the size of a golf ball, it would be a black hole. There is no physical way to compress Mount Everest or the Earth this way, but something much, much larger, like a star, has a much larger Schwarzschild radius. When the center of a very massive star collapses on itself, black holes can be created. Only stars with a mass about 20 times greater than that of our sun can produce black holes, and only under certain conditions. In large stars, there is a constant battle between pressure pushing out and gravity pulling in. When a star stops producing the nuclear reactions that keep the outward pressure at its core, the star will collapse, compacting from its own weight. The star becomes so dense that, at one point, its density is virtually infinite, and its gravitational pull is so strong that not even light can escape. At this point, the star is a black hole. Because black holes have such a strong field of gravity, they have very unique effects on light and matter. Under normal conditions, light's path is perfectly straight. However, a black hole's gravitational field is so strong that it can actually bend the path of light. This means that to a viewer, objects near and around the black holes appear distorted. The closer the light travels to the black hole, the more it bends. As we can see here, the light from the star in location B is bent by the black hole in the center, and the star appears to be in location A. Objects behind black holes appear to be in slightly different locations to us because the black holes bend the light coming off that object. This is known as gravitational lensing, and has even greater effects when the black hole is larger. At a certain distance from the singularity is the photon sphere. At this point, light doesn't necessarily get sucked into the black hole, but it doesn't escape it either. Here, light can orbit the black hole. Theoretically, this means that if you were able to be at the photon sphere of a black hole, you would be able to see all the way around the black hole, to the back of your own head. Shortly inside the photon sphere is the event horizon. Here, gravity is so powerful that nothing, not even light, can escape. This means that to someone far away from a black hole, watching an object fall into one, they wouldn't be able to see the object past this point. Past the event horizon, matter falling into a black hole would be stretched towards it as it falls. Because the end of an object closest to the singularity is under more gravity than the end of the object far from the singularity, the object stretches. This process is known as spaghettification.
If matter is massive enough, gravitational attraction will overcome all other forces going against the attraction, and it will continue to keep getting smaller until it is just a point known as singularity. At its singularity, that point is infinitely small and dense. Here is where physics breaks down. When the matter enters and sucked into the event horizon and is isolated from everything else in space, also space and time has in turn disappeared from the universe. The matter entering will be stretched and torn down to smaller than atoms and will continue to become part of the black hole's singularity.